Okay, recall our example from earlier where we had the pot on the stove and we were boiling it. And it was boiling at 212 degrees, which is the saturation pressure for 1 atmosphere, or 14.7 psi. Now we want to find out how to calculate the volume of it once some of it is boiled. So suppose we had that 1 pound and we've boiled up 10% of it. For 10% of it, the quality would be X equals 0.10. That's the fraction of vapor in the vapor-liquid mixture. 1 minus X, what would that represent? 1 minus X would represent the remaining part of the fraction of liquid. Should be 0.9. So we have 90% of the liquid left and 10% is turned to vapor. Now I want to know the volume of that mixture. Well, it's easy to see that the volume of the mixture would be a combination of the liquid volume plus the vapor volume. And these values, VF, the liquid volume, is listed in your steam table, as well as the vapor volume, VG, in a table called the saturated steam table. If we go to the saturated steam table, we find that at 212 degrees, VF is equal to 0.001671, and VG is equal to 26.782. So that would give us a mixture volume of 0.1. Let's use the liquid first. 0.9 times 0.001671 plus 0.1, the 10% of the vapor, times 26.782. And that comes to the mixture is equal to 2.680. So the volume of that 1 pound mass, or the volume of the mixture, is now 2.680 feet cubed, and we'd usually indicate it as feet cubed per pound mass as a specific volume. So if we go to a new slide, we can write this as V mixture equals 1 minus X VF plus X VG. Now that applies to any specific property that we have, or any specific property that we have in our steam table. So we can also write it for the property U, which is the internal energy. U of the mixture would be 1 minus X UF plus X UG. Write it for enthalpy, H, and entropy, and so on. Now, it's nice to also be able to calculate from the property, from the mixture property, go back and calculate the quality. It's good to quantify. This is going to be how we're going to keep track of our mixtures, and how much is liquid and how much is vapor is the quality. So suppose I had VF, or V of the mixture, is equal to 10 feet cubed per pound mass. Then I could back calculate from this equation above that X, the quality, and do the algebra. X is equal to V minus VF divided by VG minus VF. By the way, this change in volume, VG minus VF, when you go from liquid to vapor, has a name for it, and it's often listed in the tables for some of the properties, not for volume, but some properties. That would be called VFG, or the volume change on mixing. So that's a handy thing to be able to calculate X from the volume. So let's suppose I had this 10, then the X would be equal to 10 minus 0.0167, all divided by VG minus VF, which was 20, let's see, that was 26.782, minus 0.0167, and that gives us a quality for that situation of gives us a quality of 0.3730, or quality of about 37.3%. 37.3% of that mixture is now vapor. So those are two handy equations that allow us to go between liquid and vapor volumes to the mixture volume to the quality and vice versa.